student. This is Devang Shah from LG Institute of Engineering and Technology. So in our previous lecture we have discussed about the generation of AC signal, how the AC signal is being generated, making the arrangement of two magnets, and in between you have to put one conductor which is continuously moving in an anti-clockwise direction. By this way you have generated or you have combined two important magnetic fields in between, that is called the static magnetic field and dynamic magnetic field. So by the combination of static magnetic field and dynamic magnetic field you have generated AC signal. Now once you generated AC signal, then your next job is to understand the different parameters or various parameters are related with these AC quantities, right? So let's discuss the various parameters, AC parameters, those are related with the AC signals topic. So in our today's topic we are going to discuss about different conditions of various parameters of AC signal, right? Okay. Let's start with the terms are related to the alternating wave. Let us start with the terms is related. These terms are related with the alternating waveform, right? So here you can find this is the AC signal or it's a waveform where in waveform there is a time, there is a magnitude. All these components. Let's first discuss about what do you mean by the cycle in this particular waveform, right? Cycle is nothing but the representation of angle 0 to 360. So it's a complete revolution. This is nothing but the complete revolution of this conductor or a loop in between these two magnets. So here we define our first term as a cycle is nothing but the one complete set of positive and negative value of an alternating quantity is defined as a cycle, right? The amplitude for a first half cycle is positive and for another next half cycle it is a negative. So it's nothing but the one complete set of positive and negative values of this alternating quantity is defined as a cycle here. Now instantaneous value is just at any point you can just measure the value. This is called instantaneous value. So here the instantaneous value is the value of the alternating quantity. It may an AC signal or AC current or AC power at a particular instant of time in the cycle, right? So during the cycle at particular instant of time, if you measure any signal value, maybe in a voltage terms, maybe in a current terms, or maybe in a power terms, that is represented as an instantaneous value, right? Now the next is called the maximum value or amplitude, right? So here the maximum value of an alternating quantity it is like it's a maximum value of alternating quantity, positive or negative, is known as the amplitude of maximum value. It occurs twice in a one complete cycle, once in a positive half cycle and another one is a negative half cycle, right? So here you can see this red and yellow balls, they are representing the amplitudes right now, right? So it one for a positive half cycle it is maximum, for a negative half cycle it is minimum, but in negative it is maximum, right? Same way, another important parameter we define as angular frequency omega. So it is the frequency expressed in radians or second. So it is denoted by omega and it is given by omega is equal to 2 pi f, right? So it's a complete revolution. Again, one more important term we define as the frequency f. So the number of cycles per second is called the frequency of an alternating quantity. It is always denoted by f and the unit is a frequency. What does it mean? See, within a 1 second, how many cycles pass through this particular signal, or how many cycles is passed through one complete second is defined as a frequency, right? The next term we define as here is a time period t, right? So it's the time taken by the alternating quantity to complete the one complete cycle is known as the time period, right? So the time required to finish the one complete cycle we define as a time period, right? So here the reciprocal of this time period we define as a frequency, and time is unit is always in a second, right? Now our next important term we define as the phase in another sense it is an angle, right? We just talk about the angle 0, 90, 180, 270, 360. These are nothing but the angles we in our technical term we define as a phase. So the phase of an alternating quantity may be defined as its position with respect to the reference axis or the reference wave, right? So here the conductor or the loop, the wire loop, which is changing the position from angle 0 to 90, this is a kind of phase, right? Same way here, the phase difference or phase angle difference, right? So the phase difference or phase angle of the alternating quantity may be defined as the angle of the leg or lead with respect to the reference axis or a reference wave, right? So here to understand this phase difference, we have to take two signals. Let's say one signal starts at the angle 0 and another signal start at the angle 30. So here the phase difference is nothing but 30 minus 0 is a 30 angle, right? That's how all these parameters are related with the AC quantities, and whenever you are going to understand any AC circuit, these following terms you can see across your path, right? Now all these AC quantities we have to make a very common terminology, because in a real world or in a real life applications, we are dealing with AC and DC both the signals, right? So two more important values we have to figure it out. That is, one is called the average value of this AC signal, right? So it's same way, like if you want to find average value of some samples, how can you find? So just you add all these values of sample divided by the total number of samples. Same way here for this AC quantity, you can see the waveform. For the positive half cycle, we are taking the samples of the positive half cycle, and from this we can be able to find all the voltage levels like V1, V2, V3 up to V10. So there are total 10 samples, right? So we are going to add here all the voltage from V1 to V10 and divided by total number of samples is called 10. So that's how it's averaged out, right? So same way, the average value of the alternating quantity is expressed by that DC current which transfer the same charges across any circuit as it transferred by the alternating current during the same time, right? So once you check here and find this average value here, you can find the average value. So that average value for the positive half cycle. So here the V average value is nothing but the area under the curve divided by base of the curve, right? So from this you will find V average value is from 0 to pi, because we are taking only from 0 to 90 angle. So from 0 to pi, Vm sin omega t into d omega t divided by pi, right? So we are taking the samples from only 0 to pi. So once you are going to integrate this particular equation, finally you will find the average value is nothing but 0.637 into Vm. So that's what it will show us the difference from a maximum value, that is the Vm, and how many times it's a 0.637 times, that is the average value, right? So you can check all this by moving this arrow, and you are integrating the complete equation. The final value which is reached is V average is equal to 0.637 into Vm, right? The same way we can find here the root mean square of this AC signal, which is called a root RMS value or effective value. It's a full name is called the root mean square. So it is equal to the DC value which when flowing through the given circuit for a given time of produces the same heat which produced by the alternating current when flowing through the same circuit of the same time. It is given by here the V RMS is nothing but the under root of sum of all square of instantaneous values divided by total number of the values. Same thing, we are taking here half of the portion, that is a half cycle, where we are taking all the voltage levels like V1 to V10, and we are making all the square of this. So we are taking the addition and taking the square, put it in under root divided by total number of samples we define as a 10, right? So by this way we can find the RMS value where the same heat can be transferred for both the AC and DC for a same circuit and for a same time. We are taking the integration of this term where V RMS value is nothing but the under root of area under the square curve divided by base of the curve. You can find this. So my V RMS value is nothing but the under root of the total area. Now for me it's for 0 to 2 pi, 0 to 360, you will get the complete swing of this signal. So it's a under root of integration of 0 to 2 pi Vm square into sine square omega t into d omega t divided by 2 pi. Now you are taking here sine square omega t is equal to, in trigonometry you will find 1 minus cos 2 omega t divided by 2. Now you are taking the integration of this term, you will find the Vrms is equal to under root Vm square divided by 4 pi and in this particular equation, so omega t from 0 to 2 pi and sine 2 omega t divided by 2 from 0 to 2 pi. This is what the limit is. So finally you will find, finally you can see the equation where Vrms is equal to under root Vm by 4 pi into 2 pi minus 0. So the final equation is nothing but V RMS is equal to Vn by root 2. So here you will find the relation V RMS and the maximum value, that is V RMS is equal to 0.707 into Vm, right. So this two most important AC parameter where average value and RMS value, right. Now why we are learning this two value is to find the judging parameters. Now there are two most important judging parameters whenever you are going to do the generation of any signals, and if you are observing these two values of this judging parameter, you can say that now this generation is the efficient generation, right. So from this average value and RMS value, my first judging parameter I define as a peak factor, amplitude factor or a crest factor, right. This is nothing but the ratio of maximum value to the RMS value of this AC quantity is known as the peak factor, amplitude factor or a crest factor, right. So once I am going to take here the peak factor is equal to maximum value, which is called a Vm, divided by RMS value, which is called 0.707 into Vm. So it's ultimately 1 by root 2 and that is equal to 1.41. So this is called the typical value of the peak factor 1.41, right. So that will show, that will tell this generation is the efficient generation of AC signal. Same way, the another parameter we define as the form factor, right. So the form factor is nothing but the ratio of RMS value to the average value, right. So RMS value is 0.707 into Vm divided by the average value is 0.637 into Vm. Once you do this, you will find the typical value is 1.11, right. So always remember, in a peak factor is always 1.41 and form factor is always 1.11. Our plant, let's say you are generating AC signal and finally at the output you are getting these two terms as a peak factor and form factor. These two values, you can be able to say that, you can conclude that the generation of AC signal is efficient, right. Thank you dear students.